All right, good morning. Welcome back to trigonometry here. So today we're going to talk about some word problems using trigonometry. Uh, in each of these problems, they're already kind of set up, so they're going to be right triangles. And again, in order to use all of the stuff that you know so far, everything has to be a right triangle. So it's one of those things you always want to kind of double check. Is this a right triangle? So that's the first thing. Now, what you're going to do is each of these triangles, you're usually going to be given a side and an angle, and then you have to decide which side do I actually want. So in this case, okay, we have the sun is 20 degrees above the horizon. You're going to use something like an astrolabe or something like that in order to get the degrees on there. Maybe a really clever protractor, but don't worry about how this is actually measured. Okay, we're just going to take this as a given, and we're not going to question the exact measurement of what's going on here. And we have a building that's 50 meters in height, and we have to figure out how long is the shadow. So what we have to do is, looking at this, we need a shadow. So we have an opposite side of this triangle, and we'd really like the adjacent side in order to be able to get our shadow. So we have to think, okay, what trigonometric function, what trigonometric ratio is going to relate opposite, adjacent, and the angle together? Like, oh, that's tangent. So that's the first thing you're going to do is just kind of take an inventory of what do you have, what do you want? So we're going to say, okay, we want the tangent of some angle. Which angle? 20 degrees, because that's one of the things that is given, is equal to my opposite, which is 50, divided by what this side over here is going to be. We can call that x. You can call it adjacent for a, L for length. Pick a letter. So x, okay, and that's going to be our value for that. And then what we have to do is we have to go ahead and solve for the x here. Okay. So we're going to multiply both sides by our x. All right. So that's going to be x times tangent of 20 degrees is equal to 50. And then the next thing, we're just going to divide tangent of 20 degrees. I know it seems like a little bit weird, but it's going to be a number. We can divide by numbers. You can't divide by tangent of 0. That's not going to work, but that's going to be a divide. But you can certainly divide by the tangent of some other angle. And we're just going to get, okay, so this is going to be 50 divided by the tangent of 20 degrees, at which point you say, well, back way, way long ago, you have to look this up on a table, but we're going to go to our mode and we're going to just make sure that we're in degrees. Okay, that's always a thing to do. Okay, and we're just going to go ahead and do that. And we're just going to say, okay, we need 20 divided, or 50 rather, divided by, and then we have tangent of 20, and I know I'm in degrees. Okay, you close your parentheses, and then voila. And there we go. And it's going to be 137 point. It didn't tell me how high this didn't tell me how many decimal places it's going to go. Since the 50 goes to 0 decimal places, the 20 goes to 0 decimal places, let's go to 1 decimal place, and it's probably accurate enough. So it's going to be 137 points, and then we get here, we have 137.37. We're going to say 137.4 meters, and that's going to be the length of the shadow, right? And that's how you do these kinds of problems. Okay, let's do another one. All right, so let's see here. So we have a ladder leaning up against the side of a building. Uh, the foot is 12 feet away from the ladder. How far is the ground from the top of the ladder? How far from the ground is the top of the ladder if the ladder makes a 70-degree angle with the ground? Let's draw a picture. Guys, generally, I try to pick problems where the picture is already here because they don't force you to really do this very often. So we're going to go ahead and figure this out this way. So what they want to do is the foot of the ladder is 12 feet from the building. So this is going to be 12 feet. Okay. And let's see, what else do we know? We know that we have a 70-degree here. Kitty, we're not going to be playing, we're doing trigonometry. I'm going to be playing with the cat right now. So we have 70 degrees down here. Okay, I know it's breakfast time, but wow. Oh, see, he's adorable. Okay, there we go. Come on. Oh, get out of my wires. There you go. Go, 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 go. Okay, good boy. All right. He needs to help. So let's see. We're 12 feet away from the angle. We have a 70-degree angle here. And then we wanted to know, what is this length right here? Most of these problems, unfortunately, I try to find different ones, but most of these are actually tangents. So again, we want this height right here. We're going to say, okay, we need something that relates the height, the opposite, the adjacent, and the angle. Again, it's tangent. A lot of these are tangents. So we're going to say we have tangent of 70 degrees is equal to h over 12, and we just solve for h. Multiply both sides by 12, so we have 12 times our tangent of 70 degrees is equal to h. We go back to our calculators and we just say, okay, we need 12 times 70, 12 times the tangent of 70 degrees. I know I'm in degrees because we just did that. There we go. It's going to be a pretty big number. And we end up with, we have 32.96. So this is 32.96. Again, they didn't tell us how many decimal places. Your book tends to. These, I got these out of different books. They're going to say, again, just kind of looking at this, we have 12 feet, there's no decimal places. 78 degrees, there's no decimal places. If we go to one decimal place, that's probably enough. So this 6 is going to make this guy into a 1, and we're just going to say that's 33 feet. Okay, and that's what we're going to do. So 33, you could write out the feet, 33 foot, whatever. Okay, with the little tick mark, that means feet, but that's our answer for this one. Okay, let's go on to another one. Okay, find the perimeter of an isosceles triangle whose base is 40 and whose base angle is 70 degrees. Like, oh, I kind of like this problem as a head. Okay, so we have to draw an isosceles triangle. Okay, and then we know that this angle right here is 70 degrees, and we know that the base is 40 centimeters, and then we have to figure out some other stuff. Well, right now, we don't have a right triangle. So what we're going to do is we're going to cleave this down the center so that we have two right triangles. Now, when I did that, I cut this bottom part in half. This base, we're going to be looking at this triangle here, and we're going to cut the base in half and say that's 20 centimeters. Okay. This angle didn't change. That's still 70 degrees. And what I'd really like to do is figure out what's the hypotenuse. I don't really care about this altitude, right? I want to know what this side is over here, because that's what's going to help me get the perimeter of this triangle. So right now, we have to relate the hypotenuse, right? That's the side that's opposite the right angle, the hypotenuse, the adjacent side, and the angle. Okay, that sounds like a cosine to me. So we're going to say that the cosine of 70 degrees is equal to my adjacent over my hypotenuse. And I'd really like the hypotenuse. So technically, we're going to go ahead and say multiply both sides by the hypotenuse. So we have our hypotenuse here. Uh, times cosine of 70 degrees is equal to the adjacent side. Okay. I'm sorry. I don't want to do it that way. I know the adjacent side is 20, so let's go ahead. We'll change this out. We'll say 20 right here. I want to know the hypotenuse. Okay. Now, a lot of times books will solve this in a way. Older books will solve this in a way. This book solved it this way. And they said, okay, we have the hypotenuse. And they said, okay, times 1 over cosine of both sides, 1 over cosine of 70 degrees, times 1 over cosine of 70 degrees. And he said, okay, that's 20 times the secant of 70 degrees here. Sorry about that. Now, here's a problem. My calculator does not have a secant button. I only have sine, cosine, and tangent. That's it. So this is kind of a step that's like technically it's a secant, and that's okay. But you know what? I don't have a secant on my calculator. These old books, you have to go up and look at a table and do that. We're not going to do it that way. We're going to use the calculator. So we're just going to say, we're just going to invert and multiply with all of this. So we're going to say we have the hypotenuse is equal to the adjacent side, 20 divided by the cosine of 70 degrees. And that's how we're going to go ahead and figure this thing out. So we plug this thing into our calculator. So we have 20 divided by, there we are, divided by cosine of 70 degrees. That's going to be kind of a small number. So we're divided by a big number, or we're going to get a big number, right? Divided by a small number gives us a big number. So we end up with, we have 58.47. Okay. Okay, and then let's see here. And again, I'm looking at, what are my units here? We have 40, we have 70 degrees. I'm going to say one decimal place is probably what they were looking to do here. So we're just going to say this is 58.5 meters for my sides here. Going back to my triangle, okay, we know that this side was 40. We could say this is 58.5. This side is 58.5. And now to get the perimeter, we just add all of these pieces up. So we just say, okay, 58.5, 58.5. times 2, right? And then we're going to add the base, add the 40, and then voila, we get a perimeter of 157 centimeters. Okay, and that's going to be our answer, right? So yeah, this one was a little bit more complicated because we had to make the right triangle and then we had to remember to get all the pieces here together. I kind of like this problem. This would be a really good test problem for your first exam. So this is the kind of thing I like. I'm like, okay, it's good. It's a nice triangle. Okay. Okay. Let's see. Clearly we've gone forward about a decade as far as the book publishing. I found this book about 10 years later. We have a guy wire. That's a Dutch term that attaches a wire to a pole for stability. Uh, and There used to be Dutch for guide, and then it just kind of translated to English. We just call it a guy wire now. So we have goes from the ground to a cell tower. Let's see, the cell tower is 150 feet above the ground. What's the angle formed by the wire is 43 degrees. See figure. Again, most of your homework problems in the book don't force you to draw a picture. So I don't think it's fair to make you guys draw a picture when the homework never really forces you to do that. So we're going to go ahead and try to do my best to find problems that already have pictures for you, even though the first thing I want to do is draw a picture. Okay. Just because it lets me kind of mark it up and do some stuff. So this is 150. This angle was 43 degrees. And what do they want to know? How far from the tower is the guy wire anchored to the ground? They want to know what is this distance right here. Okay. So we'll call this D. Again, we need an opposite, we need an adjacent, we have an angle. It's tangent. See, I told you, most of these tangents. Okay, so we're going to say that the tangent of 43 degrees is equal to my opposite 150 over my distance. And we have to solve for a distance. So we're going to say multiply both sides by d. So we have d times tangent of 43 degrees is equal to 150. Tangent of 43 degrees is going to be a number, so we can divide by it. So we have d is equal to 150 divided by the tangent of 43 degrees. And we'll go ahead and type that guy in. So let's see here. Did they tell us? No, they still didn't tell us. So again, I have no decimal places on any of these measurements. One is probably the appropriate one to go with. So we'll go ahead and type that in. Okay, again, I know that this calculator is like fancier than the one you're allowed to use, but I'm not using it. I'm not using any of the fancy function. I'm not using any of the functionality that you don't have access to on a regular scientific calculator. Okay, so we have divided by, and let's go with where's my tangent? There it is. Tangent of 43 degrees. All right. And then equals, and then we could say, okay, that's going to be 160.85. So we could say this is 160.855. But again, I'm going to go to one decimal place because we had no decimal places in anything that we were given. So I'm going to say this is going to be 160.9. And then what were my units here? They were feet. Okay. So that's going to be my answer, right? So we're just going to keep working through some of these things. I tried to download quite a few of these so that we have, first off, we'd have a lot of different problems for us to do. And secondly, like I said, it's kind of hard to find these that have pictures of them. Hey, with any luck, one of these ends up making it to your exam. You're like, wait a minute, I remember this one from the video. That's a nice thing to have. So like, I reward you for watching the video by putting a problem on the video on your exam. So that's good. I'm not promising that's going to happen. I'm just saying that, there's only so many of these. So, you know, if I end up doing one, then too bad, so sad for me. Like you get to see your test question earlier. All right. So let's see here. We have a guy wire attached to a broken stop sign until the repairs are made. We attach the stake in the ground. The guy wire makes an angle of 51 degrees with the ground. How far away is the foot of the stop sign from the nearest to the nearest tenth of a foot? So again, this is a tangent problem, right? They want this kind of a problem here. Actually, it's not a tangent. We don't know how high the stop sign is. So we have a hypotenuse, we have an angle, and we want an adjacent side. So we have to relate what relates adjacent to hypotenuse to my angle. And oh, that's cosine. Okay. So we're going to go ahead and figure that out. So we have cosine of 51 degrees is equal to We have adjacent over hypotenuse. Okay, in this case, my hypotenuse is 8. So we have cosine of 51 degrees is equal to my adjacent side. We can keep calling it adjacent, that's fine. Divided by 8. We'll go ahead and solve for adjacent. So we say 8 times our cosine of 51 degrees. That's my adjacent side. And now it's time to get the calculator out and plug that in. So we have 8 times, we have cosine of 51 degrees. All right, your calculators, even the scientific ones at this point, are pretty modern. That's how they usually expect you to type it in. If your calculator uses a slightly different syntax, the way of typing it in, please practice. And we end up with 5.03 to the nearest tenth of a degree. That's going to be 5. And again, I think, are we in meters or are we in feet? We're in feet. Okay. Okay. So there we go. 5 feet to the nearest tenth. 5.0 if you want to be really clever about that, because the nearest tenth is 0.0. Okay, nearest tenth of a foot. Let's see, do we have another one? Oh, we sure do. All right. So let's see. We have the top of a 108-foot tall lighthouse. The angle of depression is going to be 27 degrees. They've gone ahead and marked that for us. Okay. Find the horizontal distance. So here we have to use a little bit of high school geometry, right? We have two parallel lines and a diagonal thing between them. So we have to figure out, like, where is this 27 degrees? We can put it anywhere we want. Well, not anywhere, but we're going to change this triangle around so that we have our our angle down where we would like to have it for a triangle. So let's go ahead, and we have our boat. We know that we have opposite angles here, so that's going to be 27 degrees. How high is the lighthouse? The lighthouse is 108 feet. Okay. And again, round to the nearest foot. So that's why I would have said tenth, but they want the nearest foot. So we'll do it that way. And again, they want, how far away is this? Okay. We need an opposite, we have an adjacent, and an angle. Tangent. Okay, it's always tangent. If you have to guess, okay, if you're always stuck, you're like, I don't know, guess tangent. Uh, on exams, I wouldn't say it's always the safest guess, but you're like, I really don't know. Tangent's probably going to do it for you. But double check. It's like, maybe tangent, and then check to make sure. Do you have all the pieces? So we're going to say we have the tangent of 27 degrees is equal to 108. That's my opposite divided by my, we'll call it D for distance. And then we'll go ahead and do that. Solve for D. Put the D on the other side. So we have multiply both sides by D. So we have my distance times tangent of 27 degrees is equal to 108. And again, some books will use cotangent. I don't have a cotangent button, so we're just going to divide by tangent. So we can say divide by tangent of 27 degrees, divide by tangent of 27 degrees, and equals, I know you want to help. We're not helping. Okay, go, go, go. Okay, so we're going to go with that. So we're going to say, okay, we have D is equal to 108 divided by tangent of 27 degrees. And let's go ahead and type that in. All right. Let's see here. We have 108 divided by tangent of 27 degrees. We're still in degrees. You don't have to do that in parentheses. I just like to. And we end up with 211.96. We're going to say that's 211.96. We're going to round it. That's going to be 212 feet away. Right? And that's going to be our thing. All right. Do we want to do one more? I don't. We'll do one more because this one's harder. Okay. Simon bought a new shop and wants to order a new sign for the roof from a point P. So he's standing 24 feet away here. He finds the angle of elevation to be from the ground to be 31 degrees. And then if he looks at to the top of the sign, it's going to be 42 degrees. And they want to know the length of the sign. Okay. We could do this in a couple of steps of a problem. So why don't we do that? So here we go. See, again, this is going to be a tangent because if I draw this thing out, right, really we have a problem that looks something like this. So we have our 31 degrees, okay, and we have to figure out what this height is, and then we can figure out this piece here. This is going to be 42 degrees. So what's going to happen is when I figure out this 42 degrees, I'm going to get this whole height. When I figure it out from the 31 degrees, I'm going to get that little height, and then we have to subtract them. All right, they're going to be clever. The Point P is 24 feet away, so we can do that. So we actually have two little mini problems to do here. That's not going to be too bad. So again, we want to know those opposite sides. So I'll call it H1 and H2 for the top of the sign. Okay, we'll say that's H2, top of the sign. Okay, and then we have H1, bottom of sign. That way, when we subtract the two of them, that'll make all the sense in the world. So let's go ahead and set this thing up. So we're going to say, again, we have an opposite, we have an adjacent. We're going to say that's tangent. So we have tangent of 42 degrees is equal to H2 divided by 24. Okay. In the same breath, I'm going to say tangent of 31 degrees is equal to H1 divided by 24. So we're going to go ahead and figure out what H1 and H2 are. H2, that's going to be 24 times the tangent of 42 degrees is equal to H2. 21 times the tangent of 31 degrees is equal to H1. And then we have to figure out what H2 minus H1 is. Now, what you can't do is say, oh, can I just take the 42 minus the 31 and take the tangent of that? No, it doesn't work that way. Okay, they are not a linear problem where you can't do tangent of 42 minus 31 and then say, oh, that's tangent of 42 minus the tangent of 31. No, 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 no. That would be terribly bad. Don't do that. We're going to figure out the two heights by themselves and then subtract them. Okay, they don't distribute. You can't distribute the tangent over the different things. Just like I know you've probably had college algebra by now, you've had algebra 2 by now. If I have the natural log of, say, 100 plus 30, that's the natural log of 130. I can't say that's the ln of 100 plus the ln of 30. No, 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 no. That does not work. Just same thing for trig functions. That does not work. That's a surefire way to get yourself a lot of low number of points. Okay. So don't ever do like distribute the trig function inside of the angle. So that's really why I wanted to do this problem. Okay. So we're just going to go ahead and figure out what H1 and H2 are, figure that out, and then we can go ahead and subtract. All right. So we have 24. So let's go ahead. We have 24 times, go back, times the tangent of 42. Okay. Tangent of 42. And that's equal to 21.6. We'll say 21.61. 21.61. Right. That was my H2, I believe. Yeah. So we'll just round it to decimal places because we'll round it to the nearest tenth. So we'll keep 2 so that we have 1 when we go ahead and do this. Okay, in H1, we'll say that's going to be 21 times the tangent of 31, so times tangent of 31. Okay, so there we go. So that was 12.6. So that worked out pretty well, 12.61. Okay, let's go back to here. So we have 21.6 minus 12.6. We're going to say, okay, we have 21. We have 21.6, technically 21.6. I could say it's 6.1 minus 12.61. So that, boy, this wasn't like plucked out of a textbook perfectly, was it? So they came out to be really nice numbers. 21.61 minus 12.61. Boy, that was 12.61. 0.61 equals, and then we end up with this is a 9-foot sign. Okay, so that's the height of my sign here. All right, I think that is plenty of problems for you guys to do. I'm gonna go feed that cat before he decides that you know, before he decides to get unruly and rebels. So mutinies. Okay. So thank you very much for watching the video, and I will see you in the next one.